Today, India's first solar thermal power plant is ready to generate its first load of energy. Dark clouds looming on the horizon are casting a shadow on this day.
We're just preparing for startup. So everything has to be in order before it can actually start up.
But nothing seems to be going as per the plan. The alignment of the shaft for the turbine seems to have taken longer than anticipated.
There's a minor change in the dimensions of the shaft because 25-meter long thing, and you have to achieve the tolerance of around 0.03 mm.
Until today, the team has remained ahead of time. But now, time is ticking away. And the team is struggling to keep up.
Final alignment check is happening, and then we have to connect the coupling. We are delayed by around 12 hours.
Can this mega structure prove itself in the face of adversity? Is the plant truly ready to create a milestone in Indian history? Mid-April, in Rajasthan, almost 190 kilometers from Jodhpur, the temperature soars well above 48 degrees, and the blowing sand forces the local residents to stay behind closed doors. But for the 1,500-strong workforce of Godavari Green Energy Limited, it is the perfect day to be out, because this is the weather that will transform these 400 acres of barren land into a sea of abundant energy. It is in these harsh conditions that these 4 solar fields spread over an area large enough to accommodate nearly 300 football fields will produce 50 megawatts of electricity every day. When fully operational, the plant will generate approximately 130 million kilowatt hours of electricity in a year. This is enough to meet the energy needs of around 150,000 Indians. To do that, it must first qualify for entry to the national grid. At the helm of this mega dream stands the man with a bold vision and a strong resolve. He is Mr. J.P. Tiwari, CEO and Director, Godavari Green Energy Limited.
As soon as we landed on this site, we knew that this is a completely altogether different kind of land where we have to work. We had no experience on working on desert lands. It was quite difficult to demarcate the land where we have to actually start the work with. We often lost track. We had to identify the corners of the plot, and then the local Desi jugards were used to mark the places with red flags, and that was how we started the job here.
It was on these 400 acres of barren land that the first step in a long and difficult journey was taken. The foundation for this mega structure was laid a few kilometers away from the small village of Nok, an area in India that receives some of the highest DNI, which is radiation received from the sun, as per the data from NASA and the Indian Meteorological Department.
We started with just the coordinates of this land and an idea that could power the nation sustainably.
The nation's population is well over 1 billion, and the energy needs of this burgeoning mass of humanity are soaring continuously. Today, India burns almost 700 million tons of coal every year, making our coal consumption the 3rd highest in the world. As a result, India releases close to 1.9 million kilotons of carbon dioxide every year. As of today, emissions from coal-fired power plants have caused nearly 1,15,000 premature deaths. Despite the high cost, almost 290 million Indians still live in the dark. It is estimated that by 2030, our carbon dioxide emissions from energy consumption will double, and more than 40% of our energy needs will depend on imports of fuel. Today, only 31% of our energy comes without fatal side effects. It is time we stop digging for answers in the bowels of the earth. We must stop exploiting the earth's fast-dying resources and harvest instead a source of clean, free and infinite energy. One that has been benevolently blessing us with life all this time. The sun.
ओम योगिने नमः, ओम संयुक्ताय नमः, ओम प्रकाशकाय नमः, ओम प्राप्ताय नमः, ओम प्रप्राणाय नमः, ओम सूर्य एक ऐसा पुंज है, उसके बिना जीवन, किसी भी प्रकार का जीवन, चाहे पेड़ पौधे हैं, ये भी पनपते नहीं, उसके बिना नहीं होते, क्योंकि जो वीर्य और तेज है वो इसी से प्राप्त होता है। क्योंकि जो ग्रह अपन जिस ग्रह पर रहते हैं, पृथ्वी ग्रह है और सूर्य के ही ये उपग्रह हैं, तो इन पर जो भी जीव जंतु पेड़ पौधे रहते हैं, उनको ऊर्जा जो मिलती है वो सूर्य से मिलती है, ऊर्जा सूर्य से मिलती है। और ऊर्जा अगर सूर्य से सही नहीं मिलती हो तो उसका विस्तार नहीं होता है, विकास भी नहीं होता है। इसलिए अपने धर्म में सबसे बड़ा सूर्य को माना है।
Harnessing the sun's potential is the need of the hour. It is our only chance to preserve this good green earth for our future generations.
Renewable energy is vital, not only for India but for the world itself. For this, world has now woken up that let us use the energy that God has given us.
With this aim, the Government of India launched the Jawaharlal Nehru National Solar Mission in the year 2010.
Jawaharlal Nehru mission has 20,000 megawatts to be produced by 2022, out of which the first phase, which has to end this year, it is going to be 1,300 megawatts.
500 megawatts of this power will come from a technology never tried before in India. Concentrated solar power, or CSP, also known as solar thermal technology. Concentrated solar power doesn't create electricity directly from sunlight. Instead, it captures and concentrates the rays of the sun to create heat, which is then used to generate power. With the vision of a sustainable future, Godavari Green Energy Limited set out to be the first of the 7 companies chosen under the Jawaharlal Nehru National Solar Mission to set up a solar thermal power plant in India. Godavari Green Energy Limited is a subsidiary of Godavari Power and Ispat Limited and is part of the Hira Group of Industries.
We understand the potential of green energy, not only in terms of environment, but also in terms of the economy also.
With single-minded determination, the company broke ground on the ambitious project in November 2011.
The land was acquired, financial closure done, and the next step was finding a good technology partner who can make this project a success. And then we roped in Abilene-based technology partner named Lauren Engineers.
The endless opportunities of this land soon became apparent. However, nobody in India had the requisite experience and expertise needed to set up a solar thermal power plant of this magnitude. With the experience of building a solar thermal power plant in the USA, the team behind Nevada's Solar One, Lauren Engineers, were the perfect fit for the job.
My name is Steve Doyle. I'm from the U.S. I am the Chief Construction Manager.
The first and immediate challenge that lay before Steve was the foundation of the plant's lifeline, its 4 massive solar fields. These solar fields will have to endure a temperature that varies from -2.5 to well over 50 degrees Celsius in a year, and wind that often blows at a speed of 50 kilometers per hour. The first step in the construction of the solar fields was the installation of 6,000 pylons.
This is one of the pylons that's fabricated, and then it's hot dip galvanized for corrosion protection. It should last for 25 to 30 years. This is a German design, and it has some minimal tolerances that we had to go out to fabrication shops and see if they was able to fabricate these parts for the frames, the pylons, and cantilever arms. It was a very difficult task.
The workforce took up the daunting task of installing these pylons in 240 rows. Once the pylons were erected, the crew began to assemble and install the 5,760 frames for the parabolic mirrors. Each day the crew strived to meet their deadlines and assemble an average of 40 frames a day. This task would have been challenging for a trained team of professionals. But for the untrained laborers of Rajasthan, it threatened to be nearly impossible.
One of the hardest problems to start this project, we had a training process. I had to train all the people that worked on this project. Most of the people are local people. All they've done all their life is farm. We have took time to teach them a special duty, a task that they perform. They have turned out very good work. The language was a problem, but we placed supervisors who could speak English and Hindi. So it takes 25 to 40 minutes to do both sides.
Yes, sir.
Then you pick it up and you set it on the stand.
And then our turning unit will
The
come.
turning unit will come down.
It grabs and it rotates.
Under the supervision of Hindi-speaking supervisors and Steve's guidance, the ingenious labor force proved to be quick learners.
One Indian word that I've learned in a year, over a year, is TK, okay.
Okay.
Once the frames have been declared TK, they undergo photogrammetric testing. A high-definition camera clicks 38 photographs of the frame. Its software automatically verifies the dimensions of the trough to ensure that it will accurately concentrate the rays of the sun onto the receiver tube. After this process, the frames will be ready for the most delicate and expensive component of the plant, the parabolic solar mirrors.
We had these mirrors from Flabeg. Flabeg has manufacturing units both in the US and Germany, and in fact some of the mirrors came from Germany and some from the US.
These cutting-edge $75 a piece mirrors have to be fitted onto each frame separately.
Mirror has to be as clean as possible. You need to reflect as much radiation as possible into these receiver tubes that act as thermal storage or thermal absorber. If there's a dirt on this, you have interference and the radiation going back to the absorber would be less. So you would be actually generating less or actually tapping less power from sun than what is expected out of this.
Every frame holds 28 mirrors, creating one solar collector element. These mirrors are made of white glass and are extremely thin and clear, unlike regular glass, which has a green tint due to the presence of iron. Coated with silver, one of the most reflective substances known to man, the solar collectors reflect more sunlight than normal mirrors. By the end of the construction, the plant will have 5,760 solar collector elements, or SCEs installed in rows. The length of each row is the same as that of 4 massive Boeing 747s lined back to back. The team had only 6 months to finish installing all the solar collector elements, which was no easy feat due to their very delicate nature.
There are some limitations. Just like these mirrors are so delicate, we have to run the vehicle at around 5 to 10 kilometers per hour. 12-hour shift, we are erecting around 25 to 30 panels. This is race against time, and we are trying to achieve it.
At the peak of construction on the site, thousands of workers were working hard to stay on schedule. Until they hit a roadblock. 7,835 mirrors had reached the plant in shatters. These mirrors were part of a consignment that had traveled a distance of almost 12,000 kilometers. With only a few months left for the plant to be commissioned, several rows of solar collecting elements remained to be installed. The 7,835 mirrors from one of the consignments, which had traversed a distance of over 12,000 kilometers, had reached the plant in shatters. These mirrors reflected their dreams, and as their shards lay scattered in the dust, it seemed a crack had appeared in their plans. With only a few weeks left for the plant to be commissioned, several rows of solar collecting elements remained to be installed.
These mirrors were insured. We got it replaced. It took us around 2 months to get them back from Germany. And we still feel that even though we have lost 2 months, we would be able to make it up in good time.
New mirrors arrived, and the construction resumed after a setback of 2 months. To get back on schedule was a daunting task, but armed with experience and determination, the team doubled their efforts in assembling and installing the parabolic troughs. Putting mirrors together is fairly simple. Building 5,760 parabolic troughs was a challenge. 4,000 parabolic troughs were in place. In the next 3 months, the team had to finish installing approximately 1,700 troughs to finish the plant in time for commissioning. Central to these operations is another expensive and complex piece of technology: the receiver tubes. These tubes are designed to trap the maximum amount of heat reflected by the mirrors.
This is the high-end product that actually absorbs the radiation coming in from the sun being reflected from the mirror into this. This has a property like it has a steel tube through which the STF is circulated.
Their construction involves the extremely difficult feat of welding glass with metal. This technology doesn't exist in India. The tubes at the plant are from Shot Glass, one of the only 2 companies in the world that manufacture them. These tubes reached the plant after covering a distance of more than 8,000 kilometers. Once they reached the site, 3 of them were welded together to form a single 12-meter long receiver tube. The team's target was to eventually install 17,280 of these receiver tubes. However, safely moving these tubes to the solar fields was a challenge. For their transportation, 8 custom-made carriers had to be fabricated locally, each with a capacity of 72 tubes. These thin tubes will carry 1,100 tons of heat transfer fluid, or HTF, through all 4 solar fields. This fluid will run through the 240 rows of solar collectors and heat up to a temperature of 393 degrees Celsius. This scalding liquid will then flow through seamless carbon steel pipelines. Clad and insulated with rock wool, these pipes will not let the fluid cool down. keeping the plant's commissioning deadline in mind. This heat transfer fluid was ordered well in advance and arrived at Kandla Port, Gujarat, one of the largest ports in India.
This fluid is manufactured in the United States and is transferred by bulk shipment to India. Depending on the design of the concentrated solar power plant, the plant may require anywhere from 20 to 30 metric tons of fluid for every megawatt of power. In Godavari's case, their plant capacity was 50 megawatts, and we supplied approximately 1100 tons of fluid.
This synthetic fluid must be stored at a temperature of 60 to 65 degrees Celsius and hence will remain here in these temperature-controlled shore tanks until the plant is ready. From the solar fields, the fluid will then flow to its ultimate destination, the heart of the solar plant, the power block. This steel structure, worth rupees 180 crores, is the place where the sun's heat will turn into 100% clean energy. It took a dedicated labor force of over 500 workers, working round the clock, nearly 6 months to complete this vital element of the plant. At its center lies the most expensive element, its raison d'être, the turbine. The 213-ton piece of machinery was shipped to India all the way from Sweden.
When you consider the size of the plant, you begin with turbine capacity and then you back calculate all the other things that would be serving, like the steam generation required and then the heat of the steam, and based on that the solar field is designed.
Before the turbine can begin power generation, the fluid needs to reach the steam generator. Supplied by Arlberg CSP of Germany, the steam generator weighs nearly 615 tons. Here, pipes containing HDF will exchange heat with 257 tons of water per hour, generating superheated steam up to the temperature of 385 degrees Celsius. This steam will then be used to power the turbine, which will then generate the precious megawatts. At the end of construction, each component of the plant will be fully automated using proprietary software from Rockwell Automation. Each piece of machinery, from the parabolic troughs to the turbine, will be controlled with a single click. When people come together to design the future of energy in India, it has to be ensured that their own energy doesn't run out.
Approximately 1,500 workers are working in this area, and it becomes very important for we people to create an environment so that the morale of everybody stays high and they can perform better.
And what better way to recharge than finding a family away from home? A family with which you can share your dreams, and friends with whom you can unwind and let go of the day's stress. Nok, a small Rajasthani village, which is fast becoming prosperous thanks to the newest addition to its neighborhood, Godavari Green Energy Limited.
गांव में गोदावरी कंपनी आई है तो बहुत अच्छा हुआ है। ये में बिजली उपलब्ध हो जाएगी तो माने भी सहयोग मिलेगा और गोदावरी में भी अच्छा है। कंपनी आई है तो लोग पेट भरते हैं, मजदूरी करते हैं, मजदूर लगते हैं।
For the families of Nok, the new jobs in the plant have brought new possibilities. The economic upliftment has empowered them to rise above the hard and unpredictable life of a daily wage worker and dream of a brighter future. Meet Raju and his brand new tractor. This is Raju's brother. This is their favorite ride. Raju's motorcycle. Raju wants his brother to grow up to be an engineer.
मेरे घर में 7 बच्चे और 2 लड़का। सबसे बड़ा बेटा है राजू। कंपनी में जाने से मजदूरी करने से राजू का सुधार हो गया। मेरे को बहुत अच्छा लगता है।
Raju used to be a daily wage worker, but after securing a steady job at Godavari, he was able to secure a bank loan and purchase a tractor, and is now planning to fulfill a few more dreams.
जब से राजू भैया गोदावरी में काम करते हैं बहुत अच्छे हो गए, इसमें सुधार बहुत अच्छा आ गया। बहुत करते हैं, हमारे लिए गिफ्ट वगैरह बहुत लेके आते हैं, हमारा ख्याल रखते हैं।
अच्छी मजदूरी हो रही है, अच्छी कमा रहा हूँ। अब मेरे जून को शादी होने वाली है।
This morning, the sun is shining a little brighter on Godavari. Today, Raju has a very important task to perform. Amongst his other tasks at the plant, he will drive the last panel on the 4th solar field. Meanwhile at Kandla, the heat transfer fluid has been transferred from shore tanks onto 45 road ISO tanks of 24-ton capacity each. These road tanks are on their way to the plant site, crossing 2 states and covering a distance of nearly 700 kilometers. Today, after 18 months of work, the team is entering the final innings. They have assembled the parabolic troughs that will gather the sun's rays.
This is the last trough we are erecting, and this will complete our 120th loop.
घूम के आओ फटाफट। हाँ बूम डाउन कर, बूम डाउन कर। खींच के रखो। चलो चलो, डाउन हुआ क्या इधर? दादा फिट हो गया यहाँ? डाउन ओके, बंद कराएं? ठीक है। आपको भी सर। Congratulations. Thank you. So this was the last panel that we erected, and this completes our 120th loop, and with this our solar field is complete.
Thus, the last jewel has been added to the centerpiece of this plant, the solar fields. In spite of being challenged at every step by both nature and technology, the team has met the deadline. In just 18 months, they have transformed hundreds of acres of barren land into state-of-the-art solar fields.
We are happy now, and our next step is to run the plant, start generating the megawatt. So I congratulate all of you, and let us look for the new target.
The fields are complete. The team's next challenge is to become the first of the 7 solar thermal power plants under the Jawaharlal Nehru National Solar Mission to generate power and to prove that in the long term, solar energy is a viable economic option. The heat transfer fluid has arrived from Kandla port just as the solar fields are ready. As soon as the fluid arrives, the team begins to empty the fluid from the road ISO tanks to the HDF expansion vessels. Once the heat transfer fluid is in the pipes, the pumps must be started to ensure that the fluid circulates throughout the fields. In keeping with internal deadlines, Mr. Avikal Dubey needs to have the HDF pumps up and running by tonight. It is proving to be a long night for Mr. Dubey and his team. They have been working ceaselessly with the sole agenda of having all 4 pumps running before sunrise. And just before dawn, the team meets with success.
हाँ चालू करें फील्ड में है ना One milestone you can say we have achieved that we have given command from this DCS system and motor is started in field.
It is now time for the last major process before commissioning, air and steam blowing. In this process, the pipes that will carry the superheated steam to the turbines will be cleaned.
अभी एयर ब्लोइंग की एक्टिविटी चालू होने वाली है। नॉर्मल प्लांट्स में हम लोग स्टीम ब्लो करते हैं पाइपलाइंस को क्लीन करने के लिए। पाइपलाइंस में वेल्डिंग के टाइम में कुछ अंदर डिब्रीज होती हैं, वो डिब्रीज को निकालने के लिए हमको उसको क्लीन करना होता है पाइप को, टरबाइन को डैमेज होने से बचाने के लिए।
With air and steam blowing over, the team gets busy carrying out final checks and balances before commissioning. With so many components coming together, things can often go wrong. This time, it is the solar collecting elements.
We have put these solar panels in auto mode. They will automatically track the sun. Most of the panels are right now tracking. A few have a little communication problem, like there's a command that is generated from the DCS that comes to the local panels, and few of them have a little communication problem in the fiber optic cable or in the card. So our instrumentation guys are checking them. Once these defective panels are attended, the communication is set properly. It will be put on track mode automatically, and whole solar field will start tracking the sun together as a group.
These solar collecting elements will move approximately 18 degrees per hour to track the sun, their only fuel. Of the plant are in place, and the destination of this remarkable journey is near. The day of commissioning approaches, the day when all these components will come together to generate power. The parabolic mirrors will focus the sun's rays onto the receiver tubes filled with heat transfer fluid. The HDF will then travel through all the solar collecting elements in a solar field, absorbing more and more heat. Eventually, its temperature will increase to nearly 393 degrees Celsius. This extremely hot fluid will then pass through the steam generator, where water is turned into superheated steam. Finally, this steam will drive the turbine to produce electricity. What had started out as a mega dream will today become proud reality. The day of commissioning is today. Mr. Tiwari is leaving early to take charge of the final countdown to harvest the sun.
Stresses will always be there. Things would deviate from the plan. Something new would definitely come up. we have to find out a way through it. We would all be concentrating on the turbine. So the only thing that remains is pushing the steam into the turbine, rolling it, check the condition, health of the machine, and then you just put the load.
Getting close to the commissioning, it's getting really stressed out here. People have given themselves day in and day out, and it's really getting hard, you know. Things are getting wavered, and people are trying to make sure that everything is being synchronized with each other. So yes, it's tough times, but the hard work's still going on.
There is a rush of activity as the team readies the plant to generate power for the first time. In just 19 months, the team has done the impossible, and today, India's first solar thermal power plant must prove itself by supplying power to the national grid. Everything is in order. Just the last steps remain. The turbine needs to be put in gear. Engineers from Siemens, the turbine manufacturer, are present in person to oversee the process.
We're just preparing for startup. So everything has to be in order before we can actually start up.
However, all doesn't seem to be going as per the plan. And this time, it threatens to be more than a glitch.
There's a minor change in the dimensions of the shaft because it's a 25 meter long thing, and you have to achieve the tolerance of around 0.03 mm. And so this kind of micro errors can happen with this temperature.
Until this day, the team has remained ahead of time. Today, time is ticking away, and the team is struggling to keep up. The temperature, which was ideal for solar power generation, isn't ideal for metal shafts of the turbine. Due to the extreme heat, the shafts have expanded and are currently a few millimeters too wide to be connected together. The only solution is to wait for the temperature to cool down and make the shafts shrink back to their normal size. The turbine cannot be put into gear until the shafts are aligned and connected. Time is racing ahead.
Because it is a continuous process, we cannot stop it. And you can see a tension on everybody's face. Everybody is worried about how it will start, and because we have got the time limit now, final alignment check is happening, and then we have to connect the coupling. We are delayed by around 12 hours.
Mr. Tiwari meets with his team to discuss the next course of action.
टाइम काफ़ी लग गया अलाइनमेंट में. अभी अपन स्टार्टअप कितना फास्ट कर सकते हैं, ये सीमेंस ने लोडिंग कर्व दिया हुआ है, इसके हिसाब से हम स्टार्टअप स्टीम प्रिपरेशंस करने हैं. मेन स्टीम लाइन चार्ज करना है, कंट्रोल वाल्व ESV लीक टेस्ट करना है. बट राइट नाउ वी आर रेडी फॉर रोलिंग, और रोलिंग के जस्ट पहले 10 मिनट का एक टाइटनेस चेक होगा, वो अपने को करना है.
The plant was supposed to commission today, but it was delayed because of alignment problem. But because of some unforeseen situations, it might be delayed by some few days.
Days pass as the team faces a slew of unforeseen circumstances, from technical glitches to the onset of the monsoon season, each serving to delay the final day of commissioning. After a significant delay, the day of commissioning arrives at last.
Now we stand here and we see that we have created history, and we are in a verge of commissioning the first solar thermal plant. And it itself is such a mega structure that really astonishes me, myself, and the whole team that's been involved in this project.
According to the guidelines, the plant must generate electricity continuously for 1 hour for 3 days to be declared commercially operational.
Unfortunately, due to a few teething issues, our commissioning got delayed. Today we are at the stage when we would be generating on the third day for continuously 1 hour as per the guidelines defined by Jawaharlal Nehru National Solar Mission. And doing this, we would become the first solar thermal power generating plant in the country to actually commercially operate the plant.
It is the final hour of the third day of the commissioning process. The plant has been generating electricity for the past 50 minutes. Only the last 10 minutes remain.
कितना हुआ हर सभी 55 मिनट
लोड क्या है? ओके
तेरा डीपीटी के ना बीएमपी 0.2 से 0.5 तक जा रहा है 0.2 से 0.5
फिर इसके बाद लोड बढ़ाएंगे ना?
हाँ एक बार हो जाए उसके बाद तो बढ़ा सकते हैं।
अब कितना समय बचा है? 3 मिनट?
टेम्परेचर मेंटेन रखने।
हर्ष बताना टाइम कंप्लीट होगा तो।
One minute is left.
The team waits with bated breath as they count down the final minute of power generation.
लोड कितना हर्ष?
हो गया?
हो गया 3 दिन
हो गया हर्ष?
यस सर।
आइयो।
Good job. Good job. चलो भाई लोग।
We have just finished up with our last day of early generation today, and now waiting for the certificate from the government authorities as officially commissioned.
I'm still numb from it all. It's been such a long time. It's time to go home. It feels great, actually, yes.
With the successful commissioning of India's first solar thermal power plant, the country has taken a giant step towards a cleaner, greener, and brighter future.
It's going to be a very big thing for our country, particularly because it will be the first plant which is coming up out of all those 500 megawatts that have to be generated. This is the first plant which is coming up. And it is a great day for us because this was a completely new energy. We had no knowledge whether we'll be successful in it or not, but we have done well. And the company has done very well in getting this up.